So guys, this is continuation of our last video where we started the part for sequence. Now here we will introduce bounded sequence, the concept of bounded sequence. Bounded sequence. What do you mean by bounded sequence? Suppose a sequence, it is given to us, say xn, it is given to us, and we say this sequence is a bounded sequence if it is bounded below as well as bounded above. Okay, then only we will say that our sequence, it is a bounded sequence. So how we test that a sequence is bounded or not? For that purpose we have a mathematical definition which says that a sequence xn is said to be bounded if there exists some k greater or equal to 0, in fact greater than 0, such that each term should be less than equals to that k, which holds for all n belongs to n. Okay, so every term of that sequence must be, the modulus of each and every term must be less than that particular number. Okay, this is the case for bounded sequence. And if you write it explicitly, what you have like this way, that is, this case it is for bounded below and this is the case for bounded above. Okay, fine. With this basic understanding, now we can study few examples of bounded sequence. Like you can take example 1, simplest one, 1 by n, and you can immediately observe that mod of xn should be less than 1, okay, less or equals to 1, which holds for all n belongs to n. Correct? This is a classical example for bounded sequence. One very important theorem or result which we will come across in the subsequent part, which says that every convergent sequence is bounded. Okay, but converse is not true. Converse is not true. This is result number 1 regarding this bounded sequence. In the last video we have discussed what is meant by limit or convergent sequence. Okay, so we have the idea for convergent sequence. It says that every convergent sequence is bounded, but bounded sequence, that means all the bounded sequence are not necessarily convergent. So for that first part, obviously you have a certain proof. The basic idea of the proof is something like that. Obviously proofs are not required, but just for your satisfaction I'm giving you. Basic idea is this, n tends to infinity. Okay, so this is the case for convergent sequence, and this sequence converges to x. So what we say that for epsilon greater than 0 we have xn minus x less than epsilon. Okay, for all n greater or equal to k epsilon. Okay, for epsilon greater than 0 there exists k epsilon belongs to natural number such that this one holds. Okay, fine. Now what we do here, we take minus epsilon less than xn minus x less than epsilon. Okay, we fixed our epsilon, and in the very next step we have this sort of thing. Okay, so this things works for all n greater or equal to k epsilon. After that what we do is we take the minimum of all these terms and maximum of all these terms. Okay, then we have xn lesser equal to some number k and some k dash. Okay, and k dash represents the minimum of all the terms, that is x minus epsilon and the lesser terms. Okay, minimum of all these terms, and xn x plus epsilon and the higher terms we take, and we take k as the maximum of all those terms. Okay, finally we have this sort of relation, and that immediately implies the boundedness. Okay, this is the more or less idea behind that every convergent sequence is bounded. But the converse is not. For that purpose you need to have some counter example, and it is very much important that you have a classical example like this: xn equals to minus 1 to the power n. You know that this sequence, it is bounded, and bounded by 1. Okay, it is bounded sequence. But in the last video we have discussed that this sequence, it is nothing but a oscillatory sequence, so it is not a convergent sequence. Correct? Fine. So this is one result which you can take for boundedness. Correct? Okay, now we are coming on to another section, namely monotonic sequence. These things are very much important to understand the concepts which we will discuss in the later on. That monotonic sequence, it has two parts basically. One is monotonic increasing, another one is monotonic decreasing. That is monotonic increasing and monotonic decreasing. Suppose you have a sequence given to you xn. If xn plus 1 greater or equal to xn for all n belongs to n, you will say that your sequence is monotonic increasing. If xn plus 1 less or equal to xn for all n belongs to n, then we say our sequence is monotonic decreasing. If there is no equality, then the case is for strictly increasing and strictly decreasing respectively. Fine. Okay, now suppose you have a sequence x1, x2, x3, x4, x5, xn, and so on. Okay, this sort of sequence is given to you. Suppose first three term, if we consider, and the subsequent terms, say the subsequent terms maintains for all n greater than 3. Okay, maintains this rule. Okay, that means xn plus 1 greater or equal to xn for all n greater than 3. But the first three term does not obey this rule. Okay, that is the case for finite. Except for a finite number of terms, this relation is holding, or this formula it is holding for rest of the terms, that is infinitely many terms greater than a finite quantity. Then also this is the case for monotonic increasing. Okay, similarly for the case of monotonic decreasing, if there are a finite exception, okay, then also we call that the sequence is monotonic decreasing. Correct? All right, now take few example, like example xn equals to n. If we consider, check whether it is monotonic increasing or decreasing. Obviously what you will do, xn plus 1 minus xn, you will get n plus 1 minus n, so 1 greater than 0. In fact it is holding for all n belongs to n, so it is monotonic increasing. In fact it is strictly monotonic increasing. Correct? All right, now xn equals to, say we are considering n square. Check it whether it is monotonic increasing or not. Okay, This type of simple examples are there, and you have to study these examples to get more clear idea regarding these topics. Okay, fine. Now in the last video we came across the concept of limit, correct? But we should know what is meant by limit point. Okay, suppose limit point, suppose a number p belongs to R, as we are dealing with a real sequence. Okay, so let us consider p belongs to R is said to be limit point. It has another name as cluster point of a sequence. Okay, this point P is said to be limit point of a sequence if every neighborhood of P contains infinitely many elements of the given sequence. That is, every element of P. Take every neighborhood of P, that is P minus epsilon, P plus epsilon. You take any neighborhood, it will contain infinitely many elements of that sequence. Okay, then we say that this P is a limit point. So Xn belongs for infinitely many values n. Okay, then we call P as our limit point. For example, we had in the last video that xn equals to minus 1 to the power n, the simplest example. In that case, you have minus 1 and 1, this set. Minus 1 a limit point, 1 another limit point, correct? Okay, now for in support of that existence of the limit point, we have a famous theorem, namely Bolzano-Weierstrass theorem, which guarantees the existence of limit point. So Bolzano-Weierstrass theorem, you should know the statements and the ideas should be clear via examples as well. And if you are interested, then you may have a look on the proof. So it says that every bounded sequence has a limit point. So first criteria, that a sequence it is given to you, it must be bounded. If it is bounded, then it must possess a limit point. Okay, for example, if you consider xn to be 1 by n, it is bounded, and the limit point in that case it is 0. xn equals to minus 1 to the power n, it is bounded, limit points are minus 1 and 1. If you consider xn equals to 1 plus 1 by n whole to the power n, this sequence, what will be the limit point? Let me know in the comment section. Okay, in fact it is bounded sequence. How? Check it out. Correct? Okay, now all these things we have a very preliminary, things. Now in fact these theorems, this Bolzano-Weierstrass theorem guarantees that every bounded sequence has a limit point. But unbounded sequence, what about the unbounded sequence? what about unbounded sequence? Okay, the answer of this question, it may, unbounded sequence may have limit points. These are just the outlines. You should follow standard book, study few more examples, and the things will get more clear to you. Correct. So this is the story about the existence of limit point. Now another very important concept, it is called subsequence. Subsequence, suppose a sequence it is given to you, say xn, okay, and a subsequence, it means xnk, just a part from xn you are picking up and it is your subsequence, but it should maintain obviously some rule. For example, if you consider this example, okay, if you consider this example, it has subsequence like xn equals to minus 1 to the power n, correct, x n plus 1, x2n plus 1 if you consider, or x2n. Look at x2n plus 1 will give you all the minus ones, so this is one subsequence of that sequence, and x2n will give you 1 1 1 and so on. So this is another subsequence of that sequence, correct. These are just examples, like from here you can easily construct the subsequence. Fine. Okay, now we will come across to some limit theorems, very famous limit theorems and also very helpful. Suppose limit xn equals to x n tends to infinity and limit yn equals to y n tends to infinity. We are considering two sequences, xn whose limit is x and yn whose limit is y. Fine. So the first theorem says that limit, you add them, you are going to get x plus y, sum of their limit, sentence to infinity. You subtract them, it will be x minus y. Fine. Second one says that you do the product and the limit of that product sequence is going to be xy. Third one, it is about division, xn by yn, and it is going to be x by y, that is n tends to infinity, provided yn not equals to 0 for all n to n and y not equals to 0. Fine. Fourth property, it says that limit xn equals to x, that implies limit kxn equals to k times limit xn, that is ka, that implies and obviously implied y. But here one thing you should follow, that k belongs to r minus the set of 0. Okay, so this one should also hold, that is xn, limit of this xn, it is x, that implies you just multiplied your sequence by a non-zero constant and you are going to get that constant multiplied with that limit, and it holds in the both sides. Fine. So all these things you have in your hand, And now let me know in the comment section whether the converse of all these four are true or not. This is just an open question and a very basic question as well. And in the next video we will start from this section onwards. Okay, fine, and thank you.